Welcome to InnoBuzz Java video tutorial part 16. The topic of this chapter is the applets. The applets are separate parts of the Java language. What are they? Where are they running? How can we implement the applets? We will speak about these, and also we will see the life cycle of an applet, and we will see how we can interact the applets. Let's see the overview of the chapter. We will speak about the following subtopics. How to define an applet. We will see how to implement them. We will follow the life cycle of an applet. We will make restrictions on applets. We will see the argument passing in applets. And at the end, we will talk about the applet container. What is an applet? We can call an applet any small application that performs one specific task that runs within the scope of a larger program. The applet is a special Java program typically included in the HTML page. Some way, as for example, images are included in the HTML. The HTML is the hypertext markup language. When we open a page that contains an applet, our browser downloads and starts the applet. The Java plugin software in the browser controls the launch and execution of Java applets. It creates a worker thread for every applet. It launches any applet in an instance of the Java runtime environment, the JRE software. Normally, all applets run in the same instance of the JRE. Just in some cases need a new instance, for example, an applet request to be executed in a specific version of the JRE. The applet classes extends the java.applet or the javax.swing the JApplet. If we want to use the swing components to construct our graphical user interface inside the applet. Implementing applets. The easiest way to make an applet in the HTML file is to put an applet tag inside the HTML tag. There is a code like applet code equals to myapplet, and we specify the dimensions, for example. Here, the myapplet is the name of our applet, that the class extends the applet or the JApplet. There are some other possibilities as well of deploying applets with creating jar files, for example. This is the Java archive, is an archive file format typically used to aggregate many Java class files and associated metadata and resources. This is a runnable file, which is also a compressed file, like a zip file. We can create also GNLP files by using the Java Network Launch Protocol that performs extensive operations on the user's environment. Life cycle of applets. Let's see now the methods of the applet class that defines our life cycle. First, the init method. It is the first method of the applet. It will be called firstly because the applets don't have a main method. It is used for initializing the applet typically contains the codes that a constructor would contain. The best is to keep the init method short, and our applet will load faster. The second is the start. It performs the tasks after the initialization. The start method starts the execution of the applet. It must be overridden. It isn't good for direct response to our user actions. If we need to perform computationally intensive operations, it might be better to start a new thread for this purpose. The third is the stop method. We have to override it too with the start method. It should suspend the applet's execution so that it doesn't take up system resources when the user isn't viewing the applet's page. For example, an applet that displays an animation should stop trying to draw the animation when the user isn't viewing it. The fourth is the destroy method. It doesn't have to be overridden if the stop method releases all resources, because it is called after the stop method, but it is used for finishing the applet. Restriction on applets. The web pages may contain malicious applets too. For protecting the users from them, there is a security model behind Java applets. Applets that are not signed are not trusted, and they are referred as unsigned applets. They operate within a security box that allows only a set of safe operations. On the other hand, there are the applets which are signed. They are trusted because they are using a security certificate that indicates that they came from a trusted source. The user needs to accept this certificate, and the applet runs out of the security box. It means they have extensive capabilities to access the client. Let's see the list of the operations that applets can do in security box. They can make network connections. They can easily display the HTML documents. They can invoke public methods of the other applets on the same page. There are more possibilities when we launch them by using the GNLP. For example, they can open, read, and write the shared files on the client. They can access the shared clipboard. They can access printing functions, and they can store data on the client. But there are also a number of operations that cannot be used in the security box. We will see them now. They cannot access client resources such as the local file system, executable files, the system clipboard, and printers. They cannot load the native libraries. And also they cannot read certain system properties. For example, username, user.home, user.dir, and so on. Argument passing. Passing parameter to a Java applet is quite simple. We should define the parameter in the HTML file with a param tag inside the applet tag. The param has two attributes, the name and the value. The name will specify the name of the parameter, and the value will specify the value of it. When we want to get this inside the applet, we will use the getParameter method of the applet class. In this method, we need to name the parameter what we want to receive from the page. We can pass to the getParameter a string that names the parameter that we want to use. These strings have to match the name of the param element in the HTML page. The getParameter will return the value of the parameter. All values are passed as strings. If we want to get another type, like an integer, then we will have to pass it as a string and later convert it to the type that we want inside the Java applet. An applet is not limited to use only one param. We can pass many named params to an applet, and an applet doesn't necessarily need to use all the params that are in the HTML. So the additional params can be safely ignored. The advantage of using arguments, parameters, that if we need to change the output, then we will only have to change the value of the param tag inside the HTML file. So we don't have to edit the Java applet code at all. There is also a way of communication between applets and the HTML code is by using the JavaScript. JavaScript is a client-side, weakly typed scripting language. We can use some functions of this language for passing parameters between the applets. This is kind of communication between the applets and the JavaScript. Basically, there are two ways for doing it. First is invoking JavaScript code from an applet. The Netscape.javascript.js object class enables Java applets to retrieve a reference to JavaScript objects and interact with the web page. To be able to do this, we need a plugin jar to import in this class. We have to create a new instance of it by using the getClass method. Then we have to surround this with the try-catch block because it may cause the JavaScript exception. With this object, we can reach the JavaScript functions that are implemented in the HTML page by using the setMember, the getMember, and the eval methods of the JS object class. SetMember and getMember are used to set and get the parameter of the JavaScript methods. And we can call the JavaScript functions with the eval method. The other way of communication is invoking applet methods from JavaScript code. This way we can reach the Java objects from the JavaScript code. We have to identify the applet with an ID in the script, and after this we can easily control the applet from the JavaScript. Inside the JavaScript code we can perform operations like invoking methods of Java objects. We can use the get and set methods of Java objects, and we can reach the Java array elements as well. We can also create new instances of the Java objects this way. Let us spend some time on speaking about the applet containers. What is an applet container? It is the environment that runs a Java applet and provides secure applet execution. This will be responsible for the life cycle of the applets that we were talking about. This creates the applet after loading, and this is calling the init, the start, and the stop, and the destroy methods as well. And the container defines the security box too. With desktop applications, the applet container is typically the web browser. But this container can also be an application server or a special server, for example, on a mobile device. In the java.applet package, there is the applet context interface, which has some useful methods for implementing communication between applets. It has a getApplet method that returns with a specified applet as an object, and we can call the methods of this applet. This applet has to be in the same container where the method was called. The other is the getApplets method, which returns the enumeration of applets of this container. Using these methods, we can implement message passing between applets. The advantages of these applet containers are the following. The applet containers use a sandbox security model, which is preventing the applets from accessing system resources and causing problems this way. If we run an applet in an applet container, this will provide a security and portability. The applet requests required resources directly from the application server. The applet container makes 6 steps when executing an applet. First loads it, then creates it, then initialize it and start it, and at the end it stops. And when the browser closes, the applet container calls the destroy method, which releases allocated resources and lets the applet know that it is no longer required. It is time for us now to see how the applets work in practice. First, I'm going to create an applet which is extending the java.applet.applet class. This is the simpler way. I'm going to start from an empty project, and I create a new applet. You can see that there are many possibilities that I can choose. If there is no applet in the NetBeans here, I can choose the other, and then there are going to be some categories, and inside them I can choose the Java and the applet if I don't have it. Okay. The name of it is going to be palindrome. The palindrome, as some of you might know, is a kind of word which can be read backwards the same way. So if we read it forward or backwards, it is the same thing. Okay. Now, as you can see, I have more things here set up by the NetBeans. Some Okay, I just cleared the things that I don't need. Our palindrome class looks like this. What we have to do is also make some other imports, because I'm also going to use the java.awt .star and also the event class. Okay, yes. And I'm also going to implement the action listener here. The action listener, because we are going to create some actions. Okay, now what do we need for this to be able to check? Well, I'm going to create a very simple GUI here. I use a label. This is going to be a new label. Write the sentence here. Okay. This is going to be a simple label at the left side. And I'm using a text field. For input. This is a new text field. Which is something like 80 pixels or 80 characters. Okay, I need a button. Button start new button. Check. And I need the string for the text. That's all I need here. Well, I create a panel P, which is a new panel. And I set the layout to be a new grid layout with 3 and 1, so 3 rows and 1 column, and I add my label. enter to it. Okay. I also create a new panel. P2. This is going to be for the input field. Yes. And I also add to P the P2. So we are putting them together, and also I need a new panel, P3, which is this one is going to be for the button. Start. And I also add this to P3. Okay, that's it. Actually, I can set the background, for example, here. Set background, color dot. Well, maybe it would be light gray. Okay, and the layout of the whole frame is going to be so this dot set layout. It will be a new border layout. A new border layout, and we add the P, add P to it, to the south. On the border layout, and that's it. What we need to do here is for the start button, we have to add an action listener, and this is going to be this. So the class is going to listen for it, and we are going to catch the actions here. Okay, what I need here is to implement the action performed. Public void action performed. Public void action performed with an action event. So this I have to implement for the action listener, and let's try it out. If the EVT dot get source get source is equals to our start. Then we are going to initialize a sentence. Sentence, or no, it was just text. The text is our field input dot get text. So we get the text from it, and we are going to call the paint method. First we write it. So inside the applet there can be a paint method which is going to be called when the applet starts, and we can call it explicitly also with the repaint method call, and this is going to paint the graphical user interface in the applet. So it's public void paint, and inside this we can use the graphics object, and we just check if the sentence or if our text is null. So if it is not null, so we have got something there, then we can check if it is a palindrome or isn't it. G dot draw string. Yes, is this one, and we say that the sentence equals to the following. You get the text here, and I'm going to use some parameters here, like that's right, it's just simply something that well, the best is to start with first with an x and a y. X is going to be 20, and also the y going to be 20 in the beginning, and I'm going to increase the y. Okay, and we are going to write, depending of if it is a palindrome or not, two different strings. Well, we are going to write a method for this, which is going to be called this palindrome. We are going to give the text as an argument. Okay, we are writing this method right away, and if it is a palindrome, we are going to write that it is a palindrome to this, and else just simply write that it's not a palindrome. It's not a palindrome, and that's it. So the code is this simple. Of course, we still have to write our public Boolean method, the isPalindrome, which is going to tell if our string is a palindrome or not. Well, in fact, this is not really a complicated code. We use a for cycle here with two indexes. One is the left, and it starts from 0, and the other is the right, which is going to start from the text. Well, I like to use a different name here. Text dot length. Of course, a -1, because we don't want to go over the text's end. And what we need here is do until the left is smaller than the right. We are going to go through the text from two different ways, two different directions, and we are increasing the left and we are decreasing the right. This is a general way of checking texts, and if the text has a character at the index right, which is not equal to the text dot char at left, so they have to be the same as we start from the left and rightmost characters and go inside one by one from both sides. So if it is not true, then if they are not equal, so we return the false every time, anytime we find one. And if we don't find any problem, we can return a true. So this is a simple code. Okay. Well, in fact, we have got most of the things, I think, that we need. We have to use the repaint here that I've told about. The repaint. So this is invoked here. So if the button is pressed, we are going to get the text from the input field and repaint our applet. And every time we repaint, we are checking if it is a palindrome or not. Well, just try it out. Well, as we have told, the applets have to have a HTML file, for example, or we can see it through an applet viewer as well. But inside the NetBeans, there are some built-in functions for it. So I just can simply run it, and there will be an applet viewer code for it, as we can see. Put it to the whole screen, and I type something. First, I just push some buttons, check. It's not a palindrome. Now I write some words and then backwards. I write QWERTY and backwards the same, and it is a palindrome. So it's mostly working. Now we have to see how it is working. It is an applet viewer here, but if we come here to the build, you can see that there is a palindrome HTML which is generated automatically, and there is nothing secret in it or nothing very special. We can check. This is the same thing that we were talking about. We don't need this warning. This is a generated applet HTML launcher. That's it. And it contains nothing more that we were talking about in the slides. This is only contains a simple head with a title, and also the title here, and some notes here. But the core is just one line. That this is the palindrome class in the test project directory, and the code base classes, because it comes from the classes here. So this is one directory upper. It is only showing it because the HTML is not in the same place as the class. This is a class. This is the HTML here. So that's why we need this. If it would be here inside, we wouldn't need this. And also we wouldn't need this. So we can write by hand this as well. So we only need impact a few lines, these and this. And that's it. And I also can run it from here. I use the open now to look at the HTML, but if I use the view, there's going to be a browser opened, and the HTML page is here as well. So we can see that it is working here as well. Yeah, but the size is not big enough here, because we can set the size here. I use a bigger one. And I view it. Yeah, and then we can see it now. I create a palindrome, and it is a palindrome. So we can see that these texts are inside the HTML, these two texts, and the other things that are coming from the code. And that's it. As I've told, we can do it outside the NetBeans as well. Just simply create this HTML and write the Java. We need the class file and an HTML to be able to start it. This time we didn't really need the start and the stop methods because this is not that kind of application. We just use the default things that come from the applet. But we use the paint here to create the graphics. And this was a simple applet that extended the applets, and we are going to see the G applet as well. Let's see now an example for the javax.swing.gapplet class and to extend it and create an applet via this way. This time I will use a different method. I start from the empty project and I'm going to add a new gapplet form here. I could use simply the gapplet here, but I will use the gapplet form because I also want to show the built-in functionalities in the NetBeans for creating forms. And well, I just call it calculator because we are going to create a very simple calculator here. As you can see that we have the source and the design here, just like we had when we created the swing, and there is already some codes created here by the NetBeans for us. This is a public class calculator which extends the javax swing.gapplet. So we can use everything here that is inside the gapplet, and I can use this design view also. I add a panel to this, and I create a simple GUI for this applet now. I added a panel, and what I want to do here is create this simplified calculator which is going to have two numbers, and we can push different buttons and do the most basic operations like adding and things like that. I will use two text fields for the input, and well, just give a label here with some text, and we will use 4 different buttons for the 4 basic operations here. This I'm going to call add. This one I'm going to call subtract. Just sub tr, and multiply, and this one I'm going to call div. So device. I hope I wrote it the right way. Okay, well, these buttons are not the same. Okay, you can see the designer helps me to put them into one column. That's it. And we are going to also use a label for getting the output, but I want a bigger one, and I'm going to use the change some things. Just use a Times New Roman 14 here for this label. Enter the two numbers. Enter the two numbers. Okay. This text field became very small now. Okay. Okay. Let's do it this way. Oh, I want to put this text to the center. Well, this is not the alignment. Okay, I'm not spending time on this one this time because I don't want. We could find it easily. A few minutes. Okay, no problem. This is our input field, and this is for the text. I changed the okay, and well, in fact, I just say that outcome here or something. Okay. Well, we can make this like create a GUI like this, and add the events. For the if I double click on it, it also gives an action performed. Yes. In fact, what we need here is to get our text fields, G text field 1, we have the G text field 1, and we are getting the get text. That's what we wanted. Okay, and I use the float dot parse float method for this one. This will get a float from our text field. And what we need is to do this. This is the add, the G button one. This is the add. So I just add it to the second one, and this way we are going to get a float. And what we need to do here is to write it out on this label, which is the G label 2. The G label 2 dot set text and I will put it in an extra. Well, the easiest thing would be to put it in a different variable. Float out, because then we can see what is happening. It is beginning to be too long here. Okay, I didn't want to push it, but it's okay like this. Now we've got a float, two floats added here, and we have got another float, and set text is that outcome, and we just add the out, and that's it. Okay. Well, we check if it works, and then we can write the others as well. I hope yes. We can just try. Yes, just try it with two numbers. Yeah, 10-6, it works. Well, very good, it's very good. Yes. Okay. We didn't miss anything. So now I can just simply copy this and use the minus in the next one instead of the plus. This is going to be the third one here. With this we use the multiplication, and this one we use the divising. Yes. Okay. Just try it out. I run it, and we have got this applet viewer here, in which this is loaded. We are going to change the size very soon. Well, if I add them, if I subtract them, yes, 2.5 minus 4, this is good. Multiplication is good. Dividing is good. Well, it's working. This is our applet here. Okay. I also want to show to change the size here. Let's save it, and we can view it in the browser as well. It takes a little time to load, but it is here, and we can check it. The adding, it's okay. Subtracting, multiplying, the division. Yes, it's working. It's cool. Okay. This is it. So this way we can see that we can also use the designer and put everything just like in the with the swing components that we were doing previously, and we just can very simply create an applet out of them.